All right, welcome to the Ravit Show. I am super excited. First of all, it's been a while. So hi everyone. Let me know where you're joining from, and I'm super excited for today's session because we have our interesting combo back, which is Lior and Ryan from Monte Carlo. Lior Gavish is the CTO and co-founder of Monte Carlo, and Ryan Kearns, who's the data scientist at Monte Carlo. I'm super excited to host both of them. We'll be discussing about data observability for generative AI, and much more. So feel free to ask your questions. We'll be discussing uh, many more topics. We'll be definitely discussing about the upcoming Impact event, which is the big conference that's happening on the November 8th. So feel free to let me know and ask those difficult questions to Lior and Ryan. But without any further ado, let's have Lior and Ryan up here. Hey, Lior, Ryan, welcome to the Ravit Show. Again, it's such a pleasure to have you both. I remember we spoke almost close to more than a year now. It's been a while. Time flies, but there are so many interesting topics in discussions that we should be having today for sure.
Thank you for having us, Ravit. It was so much fun last time. Excited to be back.
Yeah, it's good to be back.
Awesome.
Hey, Ravit. Hey, everyone.
Fantastic. Just for, and I'm pretty sure the audience who are joining us, they know you. But still, if we can have start with quick introductions, and then definitely we are getting into the not just the buzzword anymore, which is GenAI. Lior, can we start with you?
Sure. I'm Lior. I'm one of the co-founders at Monte Carlo. We're the data observability company. Before Monte Carlo, I ran engineering at a cybersecurity company called Barracuda. And just to give you a little bit of a reminder or an introduction to Monte Carlo, we basically help companies make their data reliable, right? And so the idea is, data teams are building a lot of products that use data heavily, whether it's analytics or machine learning models or applications like risk and pricing and inventory and things like that. And recently also generative AI applications. These products are obviously super complex, and they depend on very long pipelines that do a lot of transformations and that rely on many different sources. And those systems break just like anything created by humans, whether it's because the data changed or because the code changed and had some unintended consequence, or sometimes the infrastructure fails, right? And Monte Carlo is an observability solution, so it basically helps our customers monitor their entire stack end to end, all the way from source to end product, and basically get proactively alerted when things break, and have all the tools and information they need in order to quickly understand what happened, where it happened, why it happened, so that teams can react to it quickly. And so we basically help teams transition, from a state where when something breaks, they get an angry phone call from their customer, internal or external. We switch them to a more operational discipline where when they can kind of own issues and get alerted on them and fix them before they impact their consumers. It borrows a lot of ideas from DevOps, actually, from observability in the software engineering world. It's modeled after it, and if folks are familiar with tools like Datadog or New Relic, Monte Carlo is very much an analogy of that for people that build data products and data systems.
Yeah, thanks for that, Lior. I think interesting stuff that Monte Carlo has always done. Like, I came across Monte Carlo almost close to 3 years back, I guess, and that was the first time I spoke to Bor as well. And I was I was so happy for someone to identify such huge problem and start with a company around it. So it was fun. Ryan, what about you?
Yeah. Hey, so as Lior said, so Monte Carlo, I work here as a data scientist. I was one of the first who jumped on when we were Series A.
Yeah.
And to Lior's point about the monitoring piece of our pipelines, I sort of initially worked on building out some initial anomaly detection models, and now sort of
Hmm.
transitioned to doing more feature engineering for the general anomaly detection infrastructure that we've built and um, various tasks in unsupervised learning and time series anomaly detection there. So I've been at Monte Carlo now 3 years and loving it. Prior to that, I was a computer science student at Stanford. So I was able to do some work in the LLM space there when it was back in its infancy, 4 long
Yeah.
years ago. So it's since exploded since then, and super excited for this conversation because I think it's in a very electric space at the moment. So really glad to
Yeah,
be here.
for sure.
Ryan joined us when we had, I believe, no customers, and now more than 300 customers later. He knows a lot about our customers and how Monte Carlo works. So always excited.
Wow, that's
It's been an active 3 years.
yeah,
Yeah.
that's super exciting. I remember Ryan, a year back you mentioned, you coming out of college and this was your. Did you start with the internship or was it like the first gig that you took?
Yeah, that's a funny story we don't have time for, but I initially joined thinking this would just be an internship because I wanted to pause school during the pandemic. So I joined on with the thought I'd be doing some rather small constrained project. And we were a very small startup at the time, so I kind of pretty much just became a full-time data scientist and didn't stop
Wow,
that.
wow.
So it's been fun. It's been pretty crazy, but yeah, the space has changed a ton and we've scaled a ton. So we've got new problems now than we did even a year ago when I spoke to you. So yeah, it's been great.
Yeah, definitely. Yeah, awesome. No, I love your journey for sure. And in terms of talking about the new and evolving problems, obviously the bigger like the question that I have for you all is around the biggest challenges that you see in the Gen AI adoption world. I'm pretty sure Leo, you talk to customers day in and out, and there are so many challenges out there. Would you like to share any of those?
Yeah, absolutely. Yeah, we definitely talked to a lot of enterprises that are and it's probably safe to say that at this point everybody's looking into how to adopt Gen AI and
Right.
how to use it to solve their business problems. Um, I think there's kind of two big challenges, if you will. One is, first and foremost is probably around skills, right?
Hmm.
We'll talk more about it later today, but like building a system that really uses generative AI to solve a business problem is difficult and create and requires a lot of new new capabilities that nobody's experienced in, right? And I'm talking about things like
Hmm.
prompt engineering, like how do you craft prompts that produce good results, and it's orchestration, like
True.
how do you structure calls to your bot to get the best results, and and the idea of agents and everything. And even product and user experience is something that has a lot of depth in the world of generative AI, right? It's there's not a lot of people today that know how to map a business problem to a solution that relies on LLMs, right? And how to design the user interface for it. And while Chat GPT is probably one of the most intuitive products that's very easy to use, and from honest, probably my parents are fully capable of using it, right? But to implement a solution in the enterprise is a different ball game, and it is complicated, and
Mm.
enterprises are definitely trying to figure out how to go about it. And so far, you can hardly bring experts from the outside because there are none to hire. And so teams are definitely leaning on call it tiger teams, internal tiger teams that are tasked with experimenting and learning and understanding how to use this new technology. To get to broad adoption, to really put it in production in the broad sense of the word. Companies are going to have to learn how to scale that, how to I guess teach more people the skills that are necessary to build it, and how to better understand where it fits and where it doesn't. The second big challenge that we're seeing is definitely around the I'll call it enterprise readiness of the technology, right? Again, if you're talking about the consumer side of things, about ChatGPT, you're probably not worried too much about things like security and privacy, or cost for that matter, or even reliability and trust. But all these things are very, very important in the enterprise. So if you think about in the enterprise, it actually really matters who gets to see what information, right? You can't just expose everybody to everything, both from a compliance perspective, but also from the perspective of security and kind of common business sense, right? And so it's yet unclear, or lots of ideas, but I don't think there's clarity around how you actually do that with LLMs. There's the to get broad adoption, you also need to make building and deploying and managing those models a lot more scalable, right? It needs to be easier right now. There aren't yet, fully established technologies to serve these models, to monitor them, to deploy them, to test them, and that's going to take some work. And obviously, the part that we're kind of most excited about, from our perspective, reliability and trust, right? Like when ChatGPT gives you, hallucinates a restaurant that doesn't exist, it's not the end of the world, perhaps. But in a business context, when you're delivering a service, again, either to internal stakeholders or external stakeholders, accuracy and reliability does matter. And you need to be thinking about how to get to not 100%, obviously. Humans are not 100% either, but you need to make it consistent and reliable enough, and minimize hallucinations, so that people can actually trust the solution and adopt it and use it for business purposes. And so, yeah, lots of challenges to address before this becomes mass market, but super exciting. I think there's a lot of promise in the technology, and it already does pretty amazing things, and it'll only become more impactful as we figure out all these different challenges.
Yeah, no, I love all these details. Thanks for sharing that, Lior. In terms of, it's not even a year as of now. Like, I remember it, everything kind of when ChatGPT kind of came up. OpenAI kind of gone out and announced somewhere in the end of November. Things have evolved so much. But yeah, like you said, it's still early. But now things are kind of getting there. Y'all are kind of solving those problems and identifying it, right? So that's interesting. Talking about problems, obviously, Ryan, what do you think about it?
Yeah, well, so Lior started to mention some of the use cases, right? I think it strikes me that this is a space that's like at once completely new, and then also a repeat of similar trends we've seen in the software and data spaces before, right? So there are aspects to this that are what Lior's been saying. We're always going to need security, compliance. You're going to need to understand the limitations and permissions, the access to certain data sources that you're going to allow, let's say, an LLM application to access. And then on the flip side of that, there's some stuff that's so new, and there's so much that depends on, what generative model can we expect to be served by OpenAI in a year's time. I think it's really hard to predict. And I think that a lot of the use cases that are most compelling kind of right on the corner of being accessible in terms of what the context like models can provide and various other technical constraints. And I mean, the open source community is just explosive with these types of ideas right now, and lots of cool, live inference LLM application technologies coming out with whether you're looking at like LangChain open source projects or what is happening in the Llama ecosystem. I think it's super volatile, very hard and dizzying to keep track of, like what's top of mind to people, which is maybe why the generative AI, drumbeat seems to sound super loud on LinkedIn on occasion. But it's a super exciting space. And I mean, yeah, as you said, it's sort of, I feel like it's starting to take form compared to where we were messing with our OpenAI access earlier in the year or late last year. It's been transformative.
Okay, interesting. That kind of also, since we are on this topic of use cases as well, and I know there's a question around the use cases, and there are data scientists who are working on some of the GenAI use cases. So talking of that, what are some GenAI use cases teams can think about implementing today? What areas of business do you think GenAI will be particularly useful? And in what areas do you think it will be difficult to apply as well? Any thoughts around that?
Yeah, I think I can take us from kind of the more colloquial or casual applications of the technology all the way to sort of enterprise-ready, complete application solutions. So starting with what I do day to day, which is that we have OpenAI access, and I use it constantly to help me code. And so there's a lot of automation problems that I maybe don't want to write, but I have to write. So I need to visualize a certain plot, and I'll go to OpenAI and ask GPT-3 to give me a scatter plot with a line on the XY axis and annotate all the points that are above that line, and it'll just spit out some code that I can run in a notebook. So I think it really speeds up the exploration and development workflow for a data scientist specifically, and then across the software stack. I mean, we use CodeGPT and various other Copilot and other automation systems for assisting with unit tests, for explaining why a unit test has failed or why a build has failed. So there's a lot that's sort of immediately accessible without productizing it, right? With internal to an engineering organization. And then you can go into slightly more productized and enterprise solutions. You talk about like knowledge workflow automation. So this is where you start getting outside of the direct software user realm, and you're talking about legal teams doing document discovery or text summarization services. Financial services can similarly kind of parse through large contexts and get summarized text. Or sales teams, whether that's discovery or outbound or what have you. Those are still internal use cases. Obviously, we're now starting to talk about access to internal customer data, which is immediately where some of the flags around security and compliance that Lior has mentioned come up. And there are, I think it's just going to be a transformative technology. I think that you can think about like data democratization. We've already had a little bit of this with like WYSIWYG technologies like Looker or Tableau for democratizing data access across a team. And I just think it's going to, now that we have natural language as the interface, it's the potential user base for that is massive. And there's a lot that can be done internal to the team. I mean, support, chatbot support as well. And then there are some more, like, we can talk about more complex use cases that are going to require more advanced LLM architectures, like, sentiment analysis and semantic search and various other, more mature technologies. But that sort of runs the scale of like what type of architectural complexity you want to bring into your organization's GenAI effort, and also the guarantees on security that you're going to need to have when you're starting to feed those models access to your own data, not just the public domain internet data they were trained on.
Very interesting. Lior, what do you think?
I'll echo some of the things that Ryan mentioned, and I'm definitely, or I think by far, coding is one of the quintessential examples of something that the generative AI does pretty well. Thank you to everybody who contributed to open source. Now it's being put to good use, right? So that's definitely a very strong use case. I think there's strong use cases around content creation, where accuracy is maybe not absolute accuracy is not required. Whether it's crafting an email or a blog post or things like that, we definitely see teams doing that. And then probably the third pattern that I've seen working out really well right now is the summarization, right? Whether it's summarizing a call or a document,
Right.
or even like disparate sources of information. I've heard this really interesting use case. A company basically built an internal tool for their sales team that generates really succinct descriptions of every account, so that salespeople can actually have more meaningful conversations with customers and understand how to get better adoption on the product, how to sell more, etc. And so, definitely lots of exciting opportunities there. I think where it's more difficult to apply generative AI, at least for now, and probably in the foreseeable future, is problems where there's complex reasoning involved, right? And if you just follow Twitter or the kind of general media, you might think that LLMs can replace humans tomorrow and send all of us to the beach while they do all of our work. But the reality is it's not quite there. And when faced with open-ended problems, models struggle. Just to give you an example from our world, from data, right? Like you can absolutely give a model like a set of schemas, maybe a little bit of documentation about it, maybe not, and it'll create great SQL queries for you on top of that data to answer basic questions. But it can't take a bunch of data, of raw data, like data sources right from the source, and combine those data sets in very meaningful way and model it to answer business problems in a way that that a human data scientist or data analyst would. And so there's a gap there. It can absolutely do the last mile, but it's not yet at the point where it can do very complex reasoning. So I think that's definitely one limitation right now, and it's critical for teams to acknowledge that, like what it can and cannot do. That will highly influence the odds of success when building a generative AI system. I think probably the other kind of area where it's still difficult is where you need high accuracy with your answers, right? And we touched a little bit on it, but definitely a lot of cases where an incorrect answer is perfectly valid, when you're writing a blog post, maybe, or at least when a human can go and kind of validate and verify and edit, it can be extremely helpful. But when you want to know what's 1 + 1, you need it to be 2, right? It can be 2.1, right? And so so people implementing generative AI should really think about that, where on the spectrum they are, and like how well like a generative model can fit there, because generative models at the end of the day are not optimized to give true answers. They're optimized to give answers that look like what a human might write, right?
Exactly.
That's the mathematical definition, right? And so there's at least in the kind of vanilla use case, there's not much guarantee around accuracy or reliability. So
Yep.
Yeah,
I like that. Go ahead,
to
please,
give some
Ryan.
color, I want to mention, like, to make that concrete, because I work a lot on our tech stack directly. And in our DevOps cycle, there's, I would say, a lot of generative AI use case at the development side of the pipeline. And then when you get to deployment, it's nowhere near any of our deployment architecture. And that's for principled reasons. So I mentioned automation workflow and code generation and automation for engineers. And I want to qualify that, right? It's great for generating code. And if you need the code to be exactly right, it should not yet be allowed to do much. This is the biggest problem with GenAI hallucinations. I remember we did one internal test where we were trying to get a generative model to work on testing invariants to key production tables in our database. And we asked it, can you make sure that this table over here has no nulls in it? And it proposed dropping the table from the database to make sure that no null values were in it, which works, right? That answers my query. But you don't want that type of behavior anywhere near your production system. And so I think there's obviously the need for some declarative policies there before you go on bringing that level of automation to a more critical place, the way Lior was mentioning.
Yeah, I love it. Great explanation there. Thanks, Ryan. Also, since we are on this topic, I know there are a few questions. Let's maybe jump on questions and then we kind of. I also want to get into the bits where we talk a little about the role of data observability and quality in this GenAI tech stack, I would say. Would love to hear your thoughts. But before that, let's take one question here from YouTube. Can you provide some real world examples where lack of data observability led to significant challenges or failures in GenAI implementation? Very interesting question. I know we were getting onto this part. Any thoughts, Lior? Anything that you can share, and then we'll also ask Ryan a little about that.
Yeah, absolutely. So let me. There's a lot to unpack here, and so but before I jump into examples, it's probably important to understand how data observability even fits with generative AI implementations, right?
Mm-hmm.
And why it's even there. And it's as follows. So we talked about some of the use cases that are working really well right now, right? And one of the, and let's take code generation as an example. One of the key reasons it works so well is that there is a lot of public information out there. There's a lot of open source code that was used to train these models, right? And so they have a lot to learn from that's public. And so they can answer questions about code pretty well. And if you think about it, if you think about the business problems that people have in the enterprise, or the business problems that that enterprises are trying to solve for their customers, right, those are typically not easily answered with public information, right? If I'm a user inside an enterprise and I want to understand, I don't know, how much did I sell in last year in India, for example, that's typically not public information, right? So a generative AI model has no ability whatsoever to answer that question. And so and so like, how do you make these models useful in those scenarios? There's probably two possible answers there, depending on the use case. You might either do what's called retrieval augmented generation, or RAG, if you've been following the GenAI news, which means that the model won't necessarily answer your question directly, but rather it would query a database to do so, right? Whether it's a vector database or data warehouse or something, but it basically, instead of trying to answer that question directly, it would do something like, are there any documents or tables in the database that could answer questions about sales? And then maybe I'll craft, maybe the model will craft a query to that database that filters for, location equals India, and date equals whatever, and then basically retrieve the information from a database that is accurate and reliable and might have proprietary data, and then respond back with it, right? And so that's how you can make generative models answer questions about data that wasn't there in the training set in the first place. The other way people are kind of attempting to do it is what's called fine tuning, which is the idea of like, let's take a foundation model, right? Something that's maybe even trained on public information, like OpenAI's ChatGPT or Llama 2 from Meta or whatever. And then let's add a smaller subset, maybe as small as like several hundred examples, that have specific knowledge or patterns that are important for the business, right? And so you're basically encoding more information into the model that didn't necessarily come from a public source. Either way, whether you're doing RAG or you're doing fine tuning, what you've essentially done is you've built a data pipeline, right? Because the information that is in the vector database or in the data warehouse that's being used to answer questions in the RAG model, or alternatively, the training set which you use to fine tune the generative model, both come from taking a bunch of internal data source, aggregating them and merging them in various ways, and putting them in a data store that is available for the model, right? And that's where data observability fits in, right? The ability to monitor and meet SLAs with those pipelines is critical, because if the data in the data store or if the data in the training set is broken, is wrong for for whatever mundane reason, the generative AI application is going to be wrong too, right? It cannot overcome that, right? And that's where data observability fits in. It's the tool that basically helps you make all the underlying data that the generative model relies on reliable, or at least reliable enough for the use case, right? So to take very concrete examples, it may not even be specific to generative AI, but if you're if you're using data from an operational system to inform the table that describes your sales, right? And I know the account ID comes as null because someone pushed a code change that does not populate that field. It might go through multiple processing stages before it gets downstream to the model, but it's going to be wrong, right? The answer is going to be wrong because the database is not going to have the answer, right? It's going to have the wrong answer. And so, and there's a variety of other problems that could that could occur that might make the data wrong. Whether it's a failed job, or again, someone adding a filter to one of the intermediate transformations that has some some unintended consequence, right? And so that's where kind of data observability fits in.
Okay, that's fantastic. Ryan, anything that you would like to add?
I think Lior answered it pretty nicely. I think I would only add that my expectation, I would qualify that there's probably going to be a greater need for data observability with these sort of non-parametric information retrieval systems like RAG systems, because the data in those information retrieval settings is live, in the sense that you need to be pulling live sales data from your internal database. And now if you're doing something like building a GenAI system that can help a business analyst answer a question with a graph, you're effectively you're doing an analyst job. And we know from the current era of big data that if the data is wrong, the analyst is wrong about it. You do get these massive problems with misreporting information or making poorly informed business intelligence decisions. So I think RAG is probably the more interesting use case to look at. I also think that there's like we can get very far afield with questions to do with like what's in the training set of a large generative model, because these are trained on what's supposedly public domain internet. But
Right.
if you're, I don't want to dive too deeply into a rabbit hole here, but if you're working for a media company and you have only the rights to certain characters and you're asking some GenAI system to impersonate characters for you, it's pretty important to know what it's been trained on, what's in its corpus, and what it's willing to output for you before you go releasing that to like your general audience, and all of a sudden you could be facing copyright infringement for not knowing that your system could impersonate Donald Duck without your rights to the character. So the data is critical.
Yeah.
Like the data makes the whole model, and I think that's there will be lots of challenges to adoption in the data observability.
Fantastic. Yeah, I love it. In terms of something around the same topic, I think there's a question here from George. So George has a question around data quality aspects. How is the data quality of the training data ensured? Any thoughts there?
All right, do you want to take it, or?
Yeah, I can take this. I think there's an adage that 90% of any data scientist's time is data cleaning. That's probably still true if you're an LLM engineer. I think that, I mean, part of the, like, I guess there's a couple things that make generative AI especially interesting in the last couple of years of machine learning and AI. And one is the architecture and the scalability of it. So the fact that like GPT-4, for example, is trained on massive Azure clusters, like an unprecedented amount of compute is applied, and the architecture, which is closed sourced in OpenAI, is obviously state of the art. And then the third piece is the data. And data is oil, is gold in this industry, right? Good data makes good models. And you're gonna get, I mean, ultimately, as Lior said, these models are still just maximum likelihood estimators with really complex parameter spaces. So your model will learn to emulate the data that you feed it. And so all of the same data quality problems that you would have if you were building a more naive, simple supervised algorithm or sentiment classification algorithm, they still apply. So you're still going to have problems where you'll need to interpolate missing data sources, or you'll need to do schema coercion, or you'll need to make sure that, I mean, we can get really into the weeds about the way that the model is doing like tokenizing of word inputs and making sure that if you capitalize North America or leave it lowercase with an underscore in the middle, you want to map it to the same vector in your vector DB, or else you're going to have sort of divergent behaviors. So the quality of the training data, I'd say, is still ensured in the same way. I wouldn't necessarily say that just because the models are much bigger that previous domain knowledge that's been learned in the big data space since really the 90s or before, like none of that really goes out the window. I do think it becomes very important as you allow these systems to automate more processes inside of an application setting, if they're allowed to proactively act on that data and importantly, change that data by recalculating embeddings or what have you. Yeah, I think that the mechanisms are still very similar in that respect. So I don't know, Lior, if you have any qualifying thoughts to that. But.
Yeah, I agree. It goes back to the fundamentals, right? Like the training set for generative AI or any AI is no different to any other data set, which means it goes back to the foundations. Make sure the data is fresh. Make sure you have all the data you need and nothing more. Make sure every single feature meets the quality quality requirements that apply to that business case, right? And Ryan mentioned some examples. Make sure the schema is right. Make sure you know where it came from and understand how it was created, right? The lineage aspects of it, right? It's all the block and tackle of any data set. Like at the end of the day, generative AI models they're quite magical, but they're not magic, right? Like at the end of the day, they rely on good training sets, and those are simply data sets.
Exactly. It definitely goes back to, obviously the foundation, and then getting the ball rolling to make sure that the data quality is good enough for the model. But that brings me to another question. I know there's a few questions for our audience. I'll be taking those questions as well. But since I mentioned about the role of data observability and quality in this Gen AI tech stack, I would love to learn a little about that. So how does the concept, first of all, you can share about that, but also I would love to learn a little about the data downtime, and how does that concept apply to AI and ML models too. So yeah, Lior, maybe you want to give it a shot first.
Should I go? Okay. Data downtime refers to the idea um, of using data to measure the reliability of data, right? So data downtime, like if I explain it very taken very simply, is this idea of like when the data is broken, is not fit for purpose, right? Is not good enough to do its intended purpose. We call it downtime, right? In the same way that we would call a website not loading, we would say that the website is down, right? So in the same way, you can say that a data set is down if it's not meeting its intended purpose. And if you can define that, you can also start measuring it, right? And understanding when is it down, when is it not down. And if you can start measuring it, you can start controlling it and managing it, right? You can start understanding like, okay, how frequently do I have downtime? Why does it happen? Is it about how long it takes me to find out that I have a problem, or is it about how long it takes me to solve the problem once I know it's there? And what could I even do to prevent that problem from happening in the first place, right? And so having that definition of data downtime actually helps control for it and make data more reliable. I think you could probably make a similar analogy in the kind of AI space, all right? And you need to think about that application as a whole, right? Like AI is not just like a bunch of bits that describe a model. It's an application that's built around it, right? For example, ChatGPT, right? And that application being up means a lot of things. It means that app, like the code that's running that application and the servers are up, right? That kind of the traditional definition of software uptime or application uptime. But it also means that the model is performing well, right? Because if the model spits out wrong information, the app is not working. It's not delivering its intended purpose, right? If I ask ChatGPT what color is the sky and it tells me red, it's not working, right? And so being able to measure that and start describing when the model is down allows you to start thinking about like, okay, how do I make it better? Like how do I make it good enough, right? We don't want 100% uptime. It's not pragmatic and it's not necessary for most applications, but we do want to manage it to a certain degree. And as I said, the measurement and definition is critical because you can then, analyze and get better and improve and learn. So, Ryan, anything you want to add around that?
Yeah, I think there's a lot to be said about data downtime. We've certainly been talking about data downtime at Monte Carlo for a long time. We break it into pillars, and those pillars have sort of simple semantic definitions, like so freshness, like is the data up to date enough? And we see ML ops teams, using these types of concepts to action the problems resulting from data downtime. So maybe you have an ML ops tool and you're tracking the prediction loss as the model is served in production. And if you have like a big spike in your mean squared error, it could be due to the fact that the data serving the model has gone stale and you haven't retrained it in 6 days. And all of a sudden it's trying to use user data that's not up to date with the way that behavior has changed. And equally, like with freshness, there's also, we look at size, so like the volume of tables or the amount of data that you can feed to the model. Is that looking constant, or have you inserted an exploding join and now you've got 10 billion rows that have nulls everywhere going into your system? And the distribution of like categorical values like null fields and distinctness of things like ID columns and stuff. So there's a lot that we've written about that, and it's still very relevant here. So I guess that's all I would add.
Yeah, no, I think it's super interesting. Just being careful of time in the questions that we have already. What I'm gonna do is take a few questions real quick. I know there's this question from Eres. He's asking what is next for MLAI Monte Carlo observability. First of all, I for our audience, I would love to learn a little about. And I'm pretty sure the audience would love to learn about this as well, about the difference between ML observability and data observability. What's like the key difference, and what's the role for each of those? And then maybe we can take this question as a follow up.
Yeah, great question, Robert. So those are indeed two distinct things: ML observability and data observability.
Yep.
ML observability, there's lots of analogies, but very different problems, right? The analogy is probably both spaces are trying to make a certain system reliable by monitoring it and alerting on issues and giving people context to help them solve issues, right? But they do it in very different domains. So ML observability is designed primarily for ML engineers or ML ops folks, and it mostly focuses on measuring the performance or reliability of a model in the context of kind of online inference, right? And Ryan spoke to some of the specific metrics that are involved in that earlier, but it's this idea that if you have a model being served in production, you can keep track of its predictions, whatever the domain is, and you can start correlating it to the features that were that were input into the model, et cetera, et cetera. And so it's a lot about the online inference piece, and for the people that are responsible for it, that deploy these models and track their online performance. Data observability is designed for a different use case and different people. It's mostly focused on data engineers, data analysts, data scientists, and it mostly focuses on data pipelines, if you will, right? On the whole process that takes various data sources and combines them into, a table or a dashboard or even a machine learning model, right? One of the use cases for data observability is, you might be preparing a data set so as to train your model or to do batch inference for a model. And this can absolutely be monitored with a data observability solution. But if you're looking to, to monitor a, online inference model that's being served, that's something that you would do with ML observability, and it just looks at different kinds of stacks, different kinds of metrics, different kinds of.
Got it.
Yeah.
Interesting. Ryan, anything that you would like to add?
I think Lior did a great job. See if we can get to other questions. I think that's a good designation.
Awesome. So like obviously, like the follow-up question was what's next for Monte Carlo. So I would say in the data observability world, what's next for Monte Carlo?
In the data observability world, as always, we're mostly learning from our customers, right? And we have the privilege of working with some great data teams across the board in various industries, and applying some of these learnings to make the product better. So to give you a few examples, we're constantly working on extending our stack and our support. for the different tools that the data people use, right? We've over the years, we've built support for all of the major data warehouses, all the major BI tools. This year, we worked a lot on orchestration tools like Fivetran and Airflow
Nice.
and DBT, right? All of them have very deep integrations in Monte Carlo with very, very rich information and features. And we're now extending it even further, working on a lot of transactional databases like OLTP technologies like Postgres and MySQL and whatnot. We are looking into the streaming world, so basically Kafka integrations are coming up, and even considering adding support for the generative AI stack, whether it's Pinecone or the generative AI capabilities coming out of Snowflake and Databricks. And so that's an area of active development. We're also investing a ton in performance and in scalability, right? Not the performance of our own application, but rather helping our customers understand the performance of their data pipelines. We're basically allowing customers to understand and analyze how different workloads or how long they run and how much they cost, so that can be controlled and monitored and optimized. It has both a cost implication, but also a reliability implication, because when things run too long, they are delayed and they cause downstream consumers to have out-of-date information, and there's a reliability and user experience aspect to it as well, right? When dashboards load slow, they in some sense don't work and are not trusted, right? And so we're giving teams like a comprehensive solution to analyze all of that and optimize and manage it to performance. We're also adding a bunch of capabilities around monitoring data in new ways. One example of that is, for the first time, we're helping customers actually compare data across different data stores, right? And basically make sure that the data sets in one place are consistent with data sets in another source. We've seen that need coming up a lot with our customers for a variety of different use cases. And so, yeah, lots of exciting stuff. That's just the tip of the iceberg of what we're up to, but hopefully it gives you some ideas about what's top of mind for us.
Yeah, this is pretty interesting. And one thing that I'm kind of, also understanding from the conversation that we are having is, even in the GenAI world, I think data observability kind of plays a very important role. And it's just going to grow from here, because the things that you, Lior, Ryan, obviously the Monte Carlo team is doing is pretty interesting. I can't wait to watch this space grow up. I'm pretty sure there's something huge as well that's coming for 2024. So I'll stick to what's happening, but I also know Impact is happening next month on the November 8th. So looking forward to that too. I'll get on that question as well, what we can expect from Impact in the speakers who are joining, because the list looks pretty good. But before that, one quick question: as as the lines blurred between AI data and general tech, in the future, do you think software engineers will inevitably become either ML engineers or data engineers, or do you think these roles will remain separate? Like, that's something that I get asked a lot as well. But y'all know it better. Y'all are in the space working day in and out. Ryan, what's your take on this?
Yeah, it's a great question. I think it's one of the most interesting questions here. I don't think that I would say that all software engineers are going to become ML engineers. I do think they might all become prompt engineers, and that's a qualification. I mean, anytime there is a significant technological change in the software industry, to take a random example out of a hat, like containerization, I don't think that most software engineers became experts in how the system is actually built under the hood, but they became experts in using compute containers to get their tasks done. And similarly, I think that the software developer as user of large language model output is going to become increasingly a ubiquitous need. Lior mentioned earlier in this call that there's sort of no standards set down, and there's no education for people to be sort of.
True.
I mean, there are early, like you can be certified in prompt engineering courses on Coursera or something, but it's not like people are coming out of school with this as a central piece of their education, the same way that conventional data science techniques would be part of it. But it really makes a significant difference. I mean, before we start talking about implementing a RAG architecture, even just reprompting a system with a subtly different context is going to give you a drastic improvement in performance for certain things. And that's a real art form, I think. And there are going to be evolved standards for how to interface with these systems, I think, across the software industry. And I think that's very encouraging. I think there was some doomsday prepping that went on when LLMs hit the scene for the first time, where you're saying, like, is software engineering a dead profession now? And like, clearly it's not. I mean, there's such a rich space to be kind of augmenting the capabilities of data engineers and software engineers and data analysts and scientists with the output of these systems, because they provide that linguistic interface for getting value out of data that you previously had to go get through other cumbersome means. So yeah, I think everyone's going to become prompt engineers, and many people will become literate in the vocabulary around, like, how do I use a LangChain agent to get the thing I want done? And they're not going to know the gory details of what's going on under the hood with the foundation model. But I think that type of vocabulary is going to become really ubiquitous, and the systems will become kind of really intimately baked into the enterprise software lifecycle. So I'm excited to watch that happen.
Love it. Anything you want to add, Lior?
No, I agree with Ryan. I mean, we're not all going to become proficient in how large language models are necessarily trained or served, but we're going to use them quite a bit, and we're going to have to learn the art and craft of doing that. I don't know if it's going to be called a software engineer, a data engineer, an ML engineer, or a prompt engineer, or something else. But we'll all be users of those technologies and hopefully putting them to good use.
Oh, yes, for sure. I'm excited to see and watch this space. But talking about the future, like I said, Impact is happening next month. I'm pretty excited. I saw the lineup. I signed up immediately. What can we expect this year? What are you all excited about? I see a super interesting lineup. So, Lior, tell us more about it.
Yeah, so Impact is coming up on November 8th, I believe. It's virtual, so you can join from anywhere. You don't have to travel. We're gonna have Snowflake and Databricks sponsoring, so some great talks coming out from both of them. And these are two of the most exciting technologies in data and in general in generative AI as well. But in addition to that, we have a nice lineup of I think over 20 talks. Some that I'm particularly excited about. Billy Bean is going to come in, and if you watch the movie Moneyball, it's based out of after him. It's the idea of, like, how do you get data to perform better in professional sports, which is pretty incredible. Annie Duke is going to be there. She's pretty amazing. She used to be a professional poker player. Now she helps companies use strategies, similar strategies in making decisions under conditions of uncertainty. Eli Collins is going to be there. He's the VP of product for AI at Google, so definitely has a good understanding of how to build some of the best AI out there and how to use it in the real world. And then we're going to have a lot of speakers from great data teams at Fox, at Navan, at BetterUp, and many others, kind of explaining what they do with data and how to make it reliable. So definitely would love to see you all there. We may or may not mention generative AI there and talk about it. Hope to see you there.
No, I think I'm pretty excited and great event that you all put together every year. So looking forward to it. But one last question for both of you. If folks want to reach out and learn more from you, where can they reach out to you? Ryan, LinkedIn, or any other spot?
LinkedIn, yes, I should be tagged. You can find my LinkedIn profile on any of the Monte Carlo stuff. I'm responsive there. I'm on X. I believe you can find my Twitter profile through that, X profile.
Mm.
And my email, rkearns@montecarlodata.com. I saw a lot of questions in the chat going into more technical detail that I'd be super happy to follow up on if people want like a deeper primer. I think it's yeah, it's a fascinating technical space to be getting into. So you can definitely shoot me an email if you'd like, and happy to respond there.
Awesome. Thanks, Ryan. Lior, where can people find you?
I do hang out on LinkedIn quite a bit, so definitely connect with me there and send me a message. I
Awesome.
try to be responsive. And same, also on X, if that's what you fancy. So we'll see. I'll see you somewhere in there.
Awesome. This is great. Thanks, Lior and Ryan, for once again visiting the Ravit Show. It was such a pleasure to host you both. Can't wait to see this space evolving in y'all making so many developments in not only just the data observability space, but also connecting it with the Gen AI world. And definitely looking forward to Impact. I'll be there attending this session virtually. And also for those who wish to attend, I'll be shooting out a link in the chat so y'all can sign up for the event. And thank you to our audience for asking such interesting and amazing questions. Thanks once again, all of you. See you
Thanks,
later.
Robert. See you at Impact.
Thanks, Ravit. Really
Take
fun.
care.
Awesome.